And if you decide, yes, I'm actually going to do this, you officially are awesome. There are some simple options out there if you don't want to really get neck deep in it. Probably you may have heard of some of these. One of them I know you're aware of because it was actually at registration, and that's using the Motorola lap dock and hooking up a Raspberry Pi. And you can pretty much use any of the Raspberry Pis, the A's, the B's, the B pluses, and the 2s. That's the most simple thing. Here's an example of one. You just have to make the Frankenstein cable to connect the HDMI from the Pi into the mini HDMI on the lap dock. I actually have one of these. It does work great, but you're limited by the Raspberry Pi. The second option is the Pi Top. This has been talked about on Wired. It's been on the net for probably about 1.5 years, maybe 2 years now. Somebody turned a Raspberry Pi into a little handheld laptop. Or I guess at that point it would be called a Palm Top. You'll see the case. There's the actual Raspberry Pi itself. They put an SSD. They stripped it out of the case, did some soldering, wired it all up, and the keyboard covers up the actual battery pack. I have a friend who tried to make one of these. It works nice, but it wasn't for me. So I was looking for another option. That led me to, of course, the information, and we just lost the screen. Yes, it is a 3D printed case. Let me go back to that. Yes. The entire case right there is 3D printed. I believe the plans are online, but don't quote me on that. The next option that some people have heard of is probably the Pi Top. It was a crowdfunded campaign, and it is a fully 3D printed case, and then you get all the accessories. There's a picture of it broken down. They did custom make one of the boards for inside this, and there's the whole kit laid out. This is nice if you don't have a lot of actual hardware electronic skills for soldering, because for the most part, this is plug and play. You are going to have to do some minor soldering, but it's nothing that even an amateur couldn't do if they spend 5 minutes in practice on wires and just circuit boards that they can kill just to kind of get the hang of it. And there are plenty of YouTubes online too about simple wire or soldering techniques. If you've never done it before, don't be scared of a soldering gun. Be careful with it because it is obviously very hot, but there's no reason to be intimidated by a soldering gun. It is a tool like tons of other tools that you use on a daily basis. You just need to learn how to use it properly. Another option exists is the Novena. This was also a crowdfunded campaign, and this is actually an open source hardware solution for a laptop. I don't know if they've started shipping them yet, but these are the internals. This is definitely a little more hardcore in that you're getting a lot more power out of it. You're not using a Raspberry Pi. And that is actually one of the pictures of the prototypes that they were using with all the parts scattered all around. But again, do we really want to do things the simple way? I think in the Linux community, we like kind of getting our hands dirty, getting in way over our heads, and then realizing, oh boy, what did I get myself into? And then trying to claw ourselves out of it. So if you want to go at it yourself, which I hope you do because that's why you're here, there are some points to cover on. Obviously, these are the main things you're going to have to look for. You need to find a board that's actually going to have your CPU on it, your screen, keyboard, mouse, touchpad, whatever you want to use, your battery, and your case. And we're going to step through each one of these. Board options. Obviously, everybody knows about the Raspberry Pi. Most people know about the BeagleBone Black. These are the other main options that I would say are really good choices to start if you're looking for a solid platform, but don't want to actually get into trying to custom design your own board, because that's way beyond me. So I'm not even going to attempt that. So I'm not going to attempt to tell you how to do that. Personally, I'm a fan of the Odroids. The Odroid C1 in particular is the one that I use and I'll be showing later. It is at the same price point as the Raspberry Pi, but the CPU is about 70% stronger, and it has a gigabit NIC versus the 100 megabit NIC on the Raspberry Pi 2. If you're a person who really likes the open source and the freedom, BeagleBone Black, I have a friend who is working on a system right now based on a BeagleBone Black, is a great option. If you're really looking for some powerful hardware, Olemex boards are good. I put Minnow boards on here because they'll stand out a little different. They're actually x86 boards. So it allows you the option of being able to rely on a standard Linux distribution and not have to worry about trying to hunt down ARM projects for whatever programs you're going to use. Because it's x86, you know the software is out there because you're using it on your desktop. Again, there are other options available. I'm not going to go in and start listing them all out. A simple Google search for just development boards will bring up more options than you even think possibly exist. You're just going to have to spend the time and figure out what board is going to work best for you. I would recommend you start with an idea of what you want to accomplish and then look for a board that matches. Don't just go out there and say, okay, I want the most powerful board, because you may not need it. Again, we're building a laptop, which means you're not plugged into the wall. So battery power is something you're going to be concerned about. So you want to get a board that's going to be power efficient and still be able to accomplish the tasks that you're going to want to accomplish. As for the screen, who has heard of Adafruit? Okay. If anyone that has their hands up, is anyone next to them that is a friend of them that doesn't have their hand up? Okay, that's good. Because if you know of Adafruit and you haven't told your friends about Adafruit, they're not your friends. Adafruit is your best place to source a screen. They have, I believe, 20 or 30 different options for screens, all different sizes, all different resolutions. And the support that you will get from the Adafruit team is unparalleled. If you have problems, they will answer them. The information that they have, the hardware information that they provide freely is, from my experience, unmatched when you're looking for this. You can find cheaper LCD screens on eBay. Yes, you will. Good luck getting support from the company who's drop shipping it and doesn't know actually a thing about it. They're just doing a reseller from China. Because they're going to say, oh, well, this is the company that made it. Here's their website. And you go to the website, and it's all in Chinese. Adafruit goes through, and they actually test the boards. That's why I buy all my stuff. I'm not trying to do a sales pitch for them, but really, this is your best option for a screen. Okay. Human interface device. This is a little bit tricky, and my laptop just decided to shut off. Because you are working on a limited form factor, you're going to need to get something that's small, but yet you're still going to be able to link. Now, most people go with a Bluetooth keyboard that has a built-in trackpad. An example of that, let me go back through my screens here, is that one right there down at the bottom. It's a small Bluetooth keyboard with wireless trackpad, built-in, all-in-one solution. You can do your own custom trackpad, which I have opted to do, and I will show pictures of that later. But if you don't want to hassle with it, this is the simplest way to go. This also means, though, that you're going to have to work Bluetooth into your design, since a lot of your small development boards do not have Bluetooth on board. Now, that's not usually a problem. It's usually a USB dongle, but that is something to keep in mind. Okay. Battery. This is going to be the issue that is going to be the most complicated that you're going to have to deal with. Yeah. Most of the battery packs that you get will be the 18650 lithium-ion cells soldered together with an adapter on the end. You usually won't find them more as a raw pack than about 6,000 milliamps. Now, there are probably some people here which have external phone chargers. It's a little battery pack that you plug your USB cable in. 90% of those, if you actually crack them open, use 18650 cells in them. One thing to keep in mind, though, is just because the battery pack was labeled as being a 10,000 milliamp battery pack does not mean it's a 10,000 milliamp battery pack. You can go on to Amazon, eBay, any of those sites, as an example, and buy a type of battery called a Surefire battery. And they sell Surefire batteries that are 6,500 milliamp batteries, which is really interesting because if you call Surefire, they will tell you that the highest battery that they make right now is, I believe, 3,200 milliamp. There's an unfortunate case where a lot of batteries are being so overrated to what they actually do. So when you're looking for a battery, look for a battery. If you're looking for a battery pack, look for a battery pack that's been verified for the actual amount of power that it will do. As an alternative, you can use LiPo cells. Personally, not a fan of them for the obvious stated reason. If you charge them poorly, you will start a fire. Now, if you're in the woods and you need to start a fire and you don't mind sacrificing your computer, they're a great option. You can build your own, which is what I've done. Now, again, when you choose to go it alone, it gets a little hairy. The biggest problem you're going to have if you decide to custom build your own battery pack is actually building the charging circuit so that you can balance when you charge. I'm not going to get into all the electrical details of battery packs and balancing, but let's just say it's an extremely complicated thing because you need all the cells to charge to the same rate. But when you're using a device, different cells will discharge at a different rate. And if you're just pumping the same amount of voltage into every single cell when you're charging it, you're going to end up overvolting some cells. Some cells are going to be undervolted, and it's going to bring down the efficiency of your overpack and potentially, like with LiPo cells, cause some very bad heat issues. You can buy cells, which is what I opted to do, that have an integrated protection circuit built into them. That is what I would recommend. You are going to pay about a 30% premium on them, but you have the security of not having your project, you plug it into the wall, you go to sleep, and then you wake up and you're wondering, why can't I see anything? Okay, case-wise, you have a couple options for your case. You can 3D print your own. If you don't have a 3D printer, in most major cities, there is a hackerspace or some 3D printing club. Most of the major cities have one. Get in touch with the people there. Tell them what you want to do. Usually, they will be really enthusiastic and actually probably want to help you overall in your project. They also are a great source of information if you need help with soldering and it's not something you're not that skillful on. The hardest problem with 3D printing it is going to be actually building the model itself. If you do not have experience with CAD, you can work on it. I tried and I failed horribly. I'm actually doing my case out of aluminum sheeting. I don't have access to a CNC machine, so I actually bought aluminum sheeting and I'm cutting it and putting it all together. I actually have the case that I'm working on at the Jupiter Broadcasting booth, and if you want, you can come by and I can show you that later. 3D printing is the best option over something like aluminum or metal because obviously it doesn't conduct, which doesn't mean you don't have to insulate everything. It's also cheaper to actually get something 3D printed. But if you're talking about a laptop, you're probably going to want something that's over this big. And a lot of your entry-level 3D printers, like the one I do, is 150 millimeter by 150 millimeter printing bed, which means I can print things that are about that big, 150 millimeters, 6 inches. So a small 6-inch computer isn't going to be as effective. I wanted something that was a little bit bigger to use. If you're trying to work a keyboard into it, you've got to cram all those keys in. With the Pi top that I showed earlier, that's why the person went with that little tiny keyboard, was because size restrictions. There is unfortunately a lack of keyboard options in this space. Most of the time, the companies that are designing small keyboards are either the small little Bluetooth keyboards for use on a phone, or a keyboard that you want to plug into your desktop, which is 7 inches, 12 inches long, because you don't want a full one. So if you're looking for something in that 7 to 9 inch range, you're going to have some difficulties. Anyway, back to the case. You can carve one out of wood. My friend that's doing a Beaglebone Black project, that is what he is planning on doing. He's done woodworking for a long time, so he's gotten some balsa wood, and he's just going to carve it out exactly to fit everything in it. So that'll be really interesting when that's done. Again, CNC aluminum. If you have a CNC machine, you are the coolest person ever. I want to get to know you. Some hackerspaces have them, smaller ones. It's an option to check out. And acrylic. Acrylic, there are places online where you can design it and send off your designs, and they will cut it, drill it to all the spec that you do, and then ship it to you. Again, hackerspaces, there's usually someone around that's involved that has an ability to work with acrylic. The one thing to keep in mind with acrylic is it will break. So if you want something to be kind of able to take a beating, acrylic probably isn't your best option. Okay, so my build, which is actually sitting in a box right now because it's not done. I was working on it yesterday in the speaker's room, and I was working on it a little last night, and it's still not done. I accidentally fried my Odroid doing some work on it, so it doesn't run right now. This was the design, the form factor that I was going with. I actually have right here. Does anyone remember these old Toshiba Liberettos from the mid-90s? Does anybody remember these? I absolutely loved these units. They were small, they were portable, but they fit really well in one hand. You can walk around with it. It fits in your hand naturally. It's really sturdy. I wouldn't recommend beating it up against a wall, although I've done that. But they're a really good unit. And I like the fact that the screen was off-centered and they built in the mouse and the buttons are actually on the back of the screen. So when you're using it, you can actually hold it like this in your hand and be able to work with your GUI. So my design, I kind of wanted to follow that, but trying to find that type of mouse, I couldn't find, so I actually went with the trackpad. The other thing to keep in mind is thickness. Nowadays, when you buy a modern laptop, you're looking at somewhere between 15 millimeters and about 20 millimeters, because thin is all the new rage. I personally don't care for thin. My concern is battery life. If you're building one, you're probably not going to be able to get it that thin because you don't have the ability to custom design a battery, send off the designs to China, and have them custom make a battery in the exact shape and size and thickness and everything that you need. If you decide to go the route of using the 18650 cells, the cells themselves are, I believe, 17 millimeters in diameter. So you're automatically going to have that. And then imagine how the thickness of your keyboard sitting on top of that, you're going to be around 1.5 inches just for the bottom. It does not include the top, which your screen is. Now, I've taken some flack from friends for it being quote unquote thick. So I'm actually going to defend the thicker form factor. How many people, and I hope the hands go up, how many people have books in their house? Okay, that's good. If you go home, look at your bookshelf. Look specifically at the thickness of your books. They are all between 1 inch and 2 inch for the majority. There are some which are thinner. There are some which are thicker. But the majority of all books are between 1 and 2 inches. The height will change. The width will change. But the thickness is pretty much all in that space. Now, I don't know for certain, but my friends that work in the publishing industry, I've asked them why that is. Because it just, for a while, it was just curious that books are always that size. The font size would change, the overall dimensions would change, but the thickness was always in that window, and I never understood why. And I asked, and they asked, and eventually the answer that came back from several people, which was consistent enough for me to believe, was that way back in the day when they decided on printing books, and they wanted it to be effective for people, obviously people were carrying the books. And if you hold your hand naturally down at your side, your hand will form a C. If you look in there, it's about 1 to 2 inches. So something will naturally fit in your hand at that size, and you don't have to worry about it falling out. You don't have to worry about squeezing it. You don't have to worry about trying to grip it. It's just naturally going to fit right there. It's a natural feeling. With something thicker, your hand ends up bulging, and you're going to wear out. Your muscles are going to get tired if you're walking for long distance with it. If it's thinner, you're either going to be pinching it, or you're going to be trying to hold it and do this with it, which is an unnatural position. So if you're going to be carrying it around, this gets a little painful after a while. So for me, that form factor, I don't have a problem with it. Now, weight is obviously a concern, but as far as the thickness, personally, I would rather trade thickness size for ability to run my laptop for a long time. And you'll understand that later when I get into it. Okay, here is the choice that I made. This is the Odroid C1, as I said. It is at the same price point as the Raspberry Pi. It's a quad-core 1.5 gigahertz processor, gigabit NIC, 4 USB ports, or 5 volts. Actual moderate usage, it's going to pull about 980 milliamps at 5 volts. Max power that it can draw is going to be 2 amps. It's not going to do any more than that. This is the screen that I went with. I got it from Adafruit. It is a 7.1-inch screen, I believe. It is 1280 by 800, so it is a very high pixel density screen. At full brightness, this screen will pull 960 milliamps. So it's also, thankfully, a very low power screen compared to the one that's actually in my laptop. That is the control board. Now, I'm going to stop right here. When I said you needed to be skilled with a soldering gun, I meant it. Because if you're worried about the size and the thickness of your unit, you're going to have to start stripping off components off of these boards. For instance, the RCA jack, the VGA jack, the power connector, all of that I stripped off, which means actually going in and removing the components. And you just don't want to go in there and start ripping on them because you don't want to damage your board. A lot of boards that you will get with your screen, panels that actually drive the panel, are going to be a little thick because they're made to support every possible several possible inputs. There was one board that I was looking at which has RCA, VGA, HDMI, DVI, and DisplayPort all along one side. Well, I don't need all those options. I'm going to choose one so I can just strip all the other components off. And that is the control board to change brightness, change screen size, refresh rates, all that stuff. This is the keyboard that I went with. I got it from Adafruit. It was, I believe, $20. The reason I got this was because it was USB. I did not want to go with a Bluetooth solution. I wanted to go with USB so I could actually hard solder it into or onto the Odroid board itself. This is the smallest USB keyboard that I have found. I have not found one smaller. If you go any smaller, they all seem to go Bluetooth. This is the touchpad that I got. It is also a USB plug in on the back, which I didn't include the picture of, but I have it at the booth so I can show you. And it is a touchpad just like you would have on your laptop anywhere else. The clicks are actually on the back side. The way it was designed is that there's a little, I wish I had the picture up. There's a little barb on the back of it, so it actually rocks back and forth, and the sensors are on the bottom. I was actually going to be punching holes to the back side and then actually just putting in buttons that I could use to just directly click through. The nice thing also about this this trackpad is the wiring on it is extremely simple in that there's 5 lines. 2 of the lines are vertical, 2 of the lines are horizontal. So if you just flip them, you can change the orientation of this board completely. So if you want it to be tall or you want it to be wide, all you're doing is changing which solder points you're using on the back. These are the batteries that I decided to use. Now, these are Panasonic cells that have had the integrated protection circuit built in. Each one of these is 3,400 milliamps. That brings my entire battery capacity at right around 6,100 amps. Now, when you're using a board that max is going to, or at moderate use is going to pull about an amp, and you're using a screen that's going to pull about an amp, those batteries will last me. My goal is at least 24 hours continuous straight use. I don't know if I'm going to hit it. I have a friend who is using a Raspberry Pi, and that's lower power usage, who built it was a mid-30s amp battery pack, and they got up to about 18 hours straight use. But it's a lower power draw. My board uses a little bit more power, and I'm doubling the amount. So hopefully I can hit the 24-hour mark. That's kind of my goal. Charging is also, as I said, is going to be the fun part. I found these, and I have the links that I can give everybody. These are a board that was made by a company called PowerStream. It's an open source design, or you can just buy it directly from them. I think it was $10, so it was a deal for me. And I got 2 in case I messed one up, so I'd have spare parts. Each of these USBs will push 2 amps out. A lot of the chargers that you'll get will push 2 amps on one, 1 amp on another. I wanted to go with one that did 2 amps on both, so I had the capability to pull the extra amperage if I needed it. These are custom in that you buy the cells. You can buy them directly from them. You can buy cells from everybody else if they don't care. You simply wire up your pack, and then you solder in your positive and negative lead, and you're go. This has the integrated charging circuit built into it. It will only charge at 500 milliamps, though. That's kind of the downside. So I'm not looking forward to if I actually run my laptop for a whole day straight, and then I have to charge up a 61 amp battery. Somebody didn't turn off his phone. Charging a 61 amp hour battery on a 500 milliamp charger is not going to be fun. But that's kind of my own fault. So I'm just going to have to deal with it. This was a simple mock-up that I did for how I want to fit it. Again, you can see me using the Libretto as my size base. There's where the battery pack's going, and then having all the boards and everything on the side. Again, since I'm going for power use, I wanted to cram as much battery in there as I could. If you're not worried about long life, you can move things around to make it easier to work on. Once this unit gets together, I'm probably not going to take it apart unless I break it again, which will probably happen, so I will have to take it apart and then curse myself the fact that I didn't make it easier to work on. Now, for the keyboard and the touchpad, As I said, I'm using USB, but I want to keep things small, and I don't want to have to deal with the entire USB connector. So I thought, well, this is easy. I'll just straight solder the USB lines directly onto the motherboard. They're going to connect anyway through a connector. I can strip out the connector and save myself a good inch from the plug. Unfortunately, these USB, I don't even know what you would want to call them, the metal shielding is very difficult to get off. At least I found it extraordinarily difficult to get off. I have a hot air rework station, which basically is just a machine that heats up air and blows it out, and you can choose the rate. And it goes up to 450 degrees Fahrenheit. And I still had problems using that, getting enough heat to melt the solder joints to be able to pull the shielding off. But thankfully, I was able to manage. It just took a while. Does anybody, I'll stop it. Has anyone used a hot air rework station before? Okay. For those that haven't, like I said, it's a box that heats up air and puts it through a tube, and you just point it at it. You have to be a little careful with them because, like, mine does up to 450. So you need to limit the amount of heat you're putting onto your board to remove the component you want to remove it, because you don't want to cook your whole board. I'm new with the hot air rework station, so I don't have much experience with it, but I have heard from other friends that they have damaged other components by overheating the board trying to get a component off. So that is something to be concerned with. Again, YouTube is going to be your friend. There are videos up on how to use them. Hot air rework stations aren't that much. I think I got mine for $40. The GPIO pins had to be sacrificed, GPIO. I wasn't going to be using them anyway, so I didn't care. Thankfully, Jason Plum is not in here. He would probably be horrified that I destroyed one of his precious arm boards. This wasn't his personally, but it's still one that he likes. The reason I did this was so I could get the VGA, the LCD panel driver board down closer to the Odroid for saving space. I could have desoldered all those, but that was just more work than I wanted to mess with. Here is the charging circuit. Again, stripped off the shielding. There's the raw pins. And here is the power linked in with the LCD driver and the Odroid. As you can see, I pulled off the VGA plug and the RCA because I didn't need them and they were in the way. One thing that I will note, you can see on the ends, if you look at, okay, we got 3 boards. We'll go from right to left. We have blue, then we have that's the Odroid. Then going to the right one, that's the LCD panel. If you look at the Odroid and at the LCD, you'll see where I actually have it wired in. You'll see little black strips where cover up the leads. You can see it most on the red positive leads. That is heat shrink. Has anyone ever used hot air heat shrink before? Okay. For those that haven't, you need to get some, because this will protect you from crossing your lines and shorting things out. Basically, it's just a tube you cut. I don't actually know what material it is. I don't know if it's some type of plastic or paper or whatever. You slide it over, you solder your connection or whatever, you solder your joint. You can use it between wires, connectors and wires. You slide the heat shrink back over it, and you just apply heat to it, and it does exactly what the word says. It shrinks down and actually surrounds it and covers up your actual solder joint. This way, you don't have to worry about making a connection that you don't want to and shorting out your unit. Okay, this is the keyboard. I stripped it out of the case, saved myself a good bit of space. Actually, I believe when it was in the case, the total size was about 18 millimeters thick. Once I stripped it down and took it out of the plastic case, it was 11. So I saved myself some good space there. And again, since I'm doing my own wiring, I didn't need the long cable in the plug, so I directly wired in the wires. Now, there's a point here which I'm going to touch on later, but I'm going to say it now. So if I forget it at the end, someone please remind me. Save everything you cut off of a board because you might need it. Okay, this is the back side of the trackpad. That's the stock connector, which I didn't want, so I just pulled the pins out and redid them. And like I said, the brown and the green, if you switch them for the red and the yellow, it just simply inverts the X and Y axis. If you then invert the red and the yellow just themselves, you will change which side it's going. So if you wanted to do one, like on mine, the trackpad will be on the inside. If you wanted to put it on the outside, you're going to need to change the dimensions of the axis because it's going to be backwards from which sides, okay? So all you're doing with this one is you're simply just switching which wire is which wire. I got that online for, I believe it was $35. The company is Circ. I do not believe they sell to individuals, so you will have to find a reseller. And as you can see right there down at the bottom are the actual switches themselves, little plugs. And there's my initial horrible soldering job, which I did because it was late one night and I just wanted to get done. And then I woke up the next morning and looked at it and said, that's horrible. So I redid it. But I don't have a picture of my better soldering job. And actually, I broke one of the cables last night when I was working on it. So I got to redo it again. And here is the keyboard, touchpad, battery, and everything all wired up. Okay, things to consider. Like I said, soldering skills. Yeah, we'll get to the China part later. It's not difficult, but like anything, you're going to want to do some practice before you jump into something of this nature. Like everything, you don't start and immediately go, I'm going to be a fantastic chef. I'm just going to go into the kitchen, start throwing stuff in a pan, and I'm going to make a wonderful meal. No, you got to work at it. You got to do a little research and do some practice. Like everything, soldering is not hard, just takes a little bit of practice and experience. Okay, standards. Who has heard of standards? USB standards, or just standards in general? Okay, most of us have. Standards are a great thing. We all like standards. Who has heard of China? Okay. Who has heard of the lack of standards coming out of China when they decide to make a board? Okay. My example on this is I forget what it was. It was another system that I was using. Hold on a second. USB, the wiring is red, white, green, black. In that order. That's what the standard says. There was one that I got, it was a keyboard for another project I was helping a friend with. We stripped the ends off. We're going to solder it up. We look at the wires, and it's orange, blue, yellow, and purple. And hold on a second. What is this? Well, these colors aren't even right. The problem was we had already stripped it off and cut the other end off too. So then we're like, well, crap, we don't know actually which pin goes to which pin. Because we can logically think, well, it should be simple order 1, 2, 3, 4 on one end, 1, 2, 3 up on the other end. But that would make sense. So we had to rummage through the trash for about half an hour until we actually found the plug, stripped it out, and then actually found that actually they did switch the wires around on the other end. So save everything because you might need it. I also would recommend that if you can, use your own wiring on components. Do not trust the wiring that you're going to get if you're buying inexpensive components. The cabling that came with the trackpad looked pretty good when you looked at it and you saw the amount of insulation on it. When you actually would strip it out, I swear it was 40 gauge wire. Now, if anybody understands the gauge system with wire, you understand that 40 gauge is basically non-existent. Went to touch it with solder, and where'd my wire go? That's why initially I actually used the actual metal plugs that were still on the end because I was trusting that their solder would hold, and it didn't really hold that well. So feel free to run your own wiring because you don't know the quality of the components you're getting. And if it is like a lot of things, there is a severe push with low cost in manufacturing. They want to be able to push out 10 million units of something for the lowest possible cost. And they're not really worried about the end consumer because they're not selling to the end consumer. They're selling to a reseller. Once that reseller has that product, they don't care anymore. They've made their money. It's their problem. So you're going to run into issues where you're going to look at something and you're going to think, why on earth would someone put this super, super thin wire in it that I can't do anything with? It's because they didn't ever want you to be able to do anything with it. Okay. These are my components that I use. There's the links. I will have all these up on my personal website, which, by the way, is q5sys.sh. And if you want, you can come by the booth and I'll give you the address again. If you want to see all the different parts that I got for my build. Okay, so I wanted to leave plenty of space because I'm sure there's questions that people have. So I'm going to kind of open the floor up, and if we have questions, okay. Okay, the question was, can you ever try to carry one of these through TA? And I'm going to play the grammar teacher joke. You can try. You can. Should you? I would highly recommend it. Now, if you get a finished product that's really nice and polished, like if you go with the pie top, I don't think you're going to have much of an issue with that. If you go for the little one, which was a little handheld one, you're probably not going to have a problem. If your finished product looks somewhat legit, you're going to be okay. If you try to go through the TSA, yeah, what they don't know, if you try to like throw this in your bag and go through the TSA, your bag's not going to make it. You might make it, but that's going to be coming out. Good old TSA. Okay. Any other questions? Anybody has? Say again? I don't know what you mean by found objects.
Oh, it's like, say you have something you like, oh, like a cigar box.
Okay. The question was, have people ever used something that they have that they like as the basis for their laptop, like a cigar box or whatever? I'm sure that there are people that have. I don't know of any personally. That's more of something that the mini ITX community has really, really been big on, and I hope that transfers into what I hope will be a small burgeoning community of people that want to design their own laptops. In using something that you like for actually building your own system. I had actually for a while thought about taking one of these, stripping all the parts out, and just using this actual case because it's already made and I don't have to figure out how to design one myself. And then I got the screwdriver in my hand and I looked at it and I felt really sad. And I was like, no, I can't do that because it's going to hate me. And these are so hard to come by in their actual put together form that I just didn't. If I can ever find someone that has a load of these and they're just going to throw them away, then I will probably do that. It's kind of a joke that someone did years ago online where somebody tried to sell a MacBook online and it ended up to be a fraud thing and they figured it out. And they actually took a 3-ring binder and made a fake laptop inside a 3-ring binder and mailed it to the person. You can have fun. You can be creative with it. But again, think about what you want to use it for and where you're going to go with it. If, like was brought up, if you're planning on taking this and going through the TSA to fly just within inside the country, or God forbid you're trying to take it outside the country, what it looks like is going to matter because they don't understand in most cases that it may look scary, but it isn't scary because all they're concerned with is the perception. Any other questions? One in the back there.
Besides soldering, what type of a soldering iron do you recommend?
Okay, type of soldering iron that I recommend. That is exactly what I was going to say. Yeah. To reiterate what the gentleman in the audience said, if you're looking for a good soldering gun, Hakko is the way to go. That's actually what I have. It's HAKKO. And actually Adafruit sells one if you want. I think it's $110. That is probably the best soldering gun I have ever used. I had an older Weller precision soldering gun, and it worked really well. But once I got the Hakko, it was like, wow, I've been using something that's really not that good. The key point is you're going to want to get one that has a precision tip. Some of you have probably seen the soldering guns that are actually shaped like a gun and have the 2 leads that come out and then connect at the end. Has anybody seen those? Okay, those are not what you want to use. Not what you want to use. You will melt everything all over your board. You will get one that it will look like the end of a needle at the end. Hakko is the best option I can give you. Are there any other questions? Thoughts, concern? One back over here. Hold on. We got a mic coming. That way everybody can hear you.
That's just a short question. What was the total cost of your build?
Oh, you really don't want to know. Which is a good point.
In dollars, not in dollars, not person hours.
The question was, what is the total cost of my build? And thank you for bringing that up because that was something I wanted to bring up and I forgot. Do not think this is going to be a budget way to build yourself a laptop on the go. Don't. It's not. My batteries alone cost me $240. That's just the batteries. The Odroid itself was $35. See, the screen was $110. That comes with a control board. The keyboard was $15 to $20. The trackpad was $35. It adds up real quick. Plus, there's all the accessories that you're not thinking of. For instance, if you're going to run your own wiring, well, now you got to go out and buy the wiring. It doesn't cost much, but it's an added cost. If you're going to do a case, okay, if you're going to do acrylic, you're going to have the case cost if you're shipping the design out to get someone else to print it. I have no clue what that costs. If you're 3D printing yourself, you're just buying the filament and using however much you need to get your design right. If you're using a 3D printing service where you send them the STL files, you're going to have to look at what their costs are. As far as my total cost of what I've actually put into it, I would guesstimate somewhere around $400 to $500 right now. For $400 to $500, I could have gotten a much powerful retail laptop, but it doesn't have the cool factor of saying I built that. Of course, it's also probably going to be a whole lot less reliable because I built that. We have in the back.
One of the other things that you should take into consideration is that you built a laptop with literally 3 times the battery capacity of a standard laptop.
Yes, then that,
Yeah.
again, this is what the gentleman was saying. You know, I built it with 3 times the capacity. That was my design impetus. That was the reason I wanted to do this, because I spend most of my day away from power outlets. So I need a laptop or a system that I can use that's going to last. I have a charger that I can plug into my car, but that's only going to give me 30 minutes of juice when I'm driving from point A to point B, and then I'm back out of my car again. So yeah, the cost for me, it's acceptable. Obviously, that's why I did it. And it's kind of a hobby. I mean, I think a lot of us spend money on things that are hobbies that we're not really concerned cost maybe more than if we did it another way, because we're enjoying the whole process. Other questions? Hold on one sec. Hold on, we got a microphone coming.
You don't have any disk storage in your laptop that you mentioned.
Oh, thank you. The Odroids they can use for the OS. They can use an SD card like a Raspberry Pi, or they also use what's called an eMMC module, which I do have listed here. It's a 16 gig eMMC module. It's basically like an SSD, but for these. Your read-write speeds are around 150 megabytes a second. So a whole lot faster than using just a simple SD card. So I have the entire OS loaded on that. I don't have any external storage or internal storage beyond that. I still have, if I can get to it real quick, on the Odroid. Yeah, let him switch the thing over real quick. I still have 2 of the USB ports on there. So I can still plug in an external drive at that point, USB flash drive, whatever. Okay, there's another question back. Hold on one moment. We have the mic coming around, and I see your hand, so.
What were your plans for when you first had the idea? What were your plans for the laptop? What exactly were you going for when you built it?
Okay. The question was, what were my original plans when I designed? My original plans were something about this size that would last me all day long. It's convenient, it's small, it's portable, it fits in my pants pocket, it's nice and useful. And again, battery life was my main thing. We had a question over here.
Going back to the battery life, it looked like you are drawing much more power than what's coming in from your charger. So when are you charging it, and how long?
Okay, when I was building the unit, I got about 90% of it done, and then I burnt out my Odroid. I cooked it. So I haven't actually been able to run the thing continuously to see how long it can actually last. That's why I said my target is 24 hours. Am I going to reach it? I believe I will, but I don't know. The other thing to mention with this charger is on chargers that will pull power that you can buy like this one for battery packs, your efficiency goes downhill very fast when you're pulling power from it and you're trying to charge from it at the same time. I don't recommend it whatsoever. On a regular laptop, the charging systems are designed so you can be using your system full power, have the charger in, and you're still going to charge your batteries. On a lot of your custom packs, or even like the phone charger packs that you get, trying to charge the pack itself while you're pulling current from it to use your device, your efficiency tanks out completely. I believe the one charger I was looking at before was rated at actually 80% inefficiency if you're trying to charge it and pull at the same time. So it's why even try? But my charging time will probably be longer than my actual how long I can use it once it's actually charged. But at this point, I don't know length. Hopefully next year I'll have everything done by then, and I won't have bought 3 more boards because I messed them up. And then I can start the thing Friday when self starts, and we can just let the thing run continuously and see when it dies. Another question over here.
Hi. Wanting to know, with your charging board, does that have feedback back to your actual Odroid to tell you if it's charging and by how much?
Okay, the board, yes. On the board, if you look, right here, it's in the center on the top. There's that arm that kind of shoots out at the top. There are actually LEDs on that, and that will give you a rating as far as if your pack is charged. How accurate is it? I'm not entirely sure. It may say it's fully charged when it's only 80% charged, because all that is doing is simply detecting how much current it's putting into the batteries versus how much is actually coming back. Another question right back there in the back.
What would you recommend for what method would you recommend for dealing with potential shock issues? Like, let's say you had it in your backpack, knocked over your backpack off your chair, and it hits the ground. How do you keep it from turning into a nice, expensive paperweight?
Personally, what I'm doing is, since I have a 3D printer, I'm using a filament called Ninja Flex, which basically acts like rubber once you print it. And I'm actually printing up flat pads. I have some of them at the Jupiter Broadcasting booth that I can show you, which I'm actually going to be lining the individual components with, so there is some type of shock absorption. Most laptops actually don't have shock absorption built into them. If you strip down the case, you'll see that the case is pretty much just hard plastic or metal or whatever it's made of, and no consideration is given to if you drop it down the stairwell, because you shouldn't be dropping it down the stairwell. When you do, it's the, oh, I hope that lasted. But that's not really something even on the commercial scale that they're really that concerned with. I went with it just because I know sometimes I'm clumsy and I stick something in my pocket and I'm driving down the road and then I get out. I don't think that it slid a little and oops, there it goes. So you can do that. That's also going to depend on what you're actually using to build your case. If you're building it out of aluminum, you're probably not going to have to worry about the shock value as much because your board is going to be locked on very well. So as long as you can, if you're using something like aluminum, CNC aluminum or whatever, as long as you can secure your components to the board securely, you should be okay, as long as you insulate them from each other. And we have another question right here. Wi-Fi, don't have it. Again, I have 2 USB ports. The question was if I have Wi-Fi. The answer is no. With the 2 USB ports, I have the capability of just taking a USB Wi-Fi dongle and slapping it in, which also reminds me about audio. Different microboard or development boards have different things with audio. The Odroid C1 actually does audio out of the HDMI, so that's not really going to work for me. So what I had to do is actually buy a small USB audio dongle, which I'm just going to strip out of the case and then take the raw plugs and fit them into the side somehow so that I can then just hook in a set of headphones with. Any other questions? Actually, did I don't know if I think I listed that in the notes as far as the parts. If not, if you want to know about the USB thing, you can get them anywhere. Mine is actually on a cable, so it flexes, which is real nice because then I can wire the cable however I need to. I have that at the booth and I can show you. Yeah, I did USB audio. Any other questions? One over here on the side. Well, it's not completed yet. Let me put it this way. It's lighter than my ThinkPad. With all the components kind of mashed together and picked up, it's, I would say, probably about 75% the weight of this. It is, of course, size-wise, that weight is more densely packed. So hopefully it won't be that bad. With the way that I laid out the batteries inside the case, since they're all flat and all next to each other, I'm hoping that the weight's going to be balanced enough that it's not going to feel weird, like one side is weighted a little heavier than the other. That's one of those things that, you know, the best laid plans of men. Let's hope it works out the way I hope. Any other question? Another one's right here.
what are you going to use this thing for? Do you have a purpose for it? Or just play with it?
Well, the question was, what is my purpose for this? What am I going to use it for? I guess the same thing I would use a regular laptop for. The biggest problem, like I said, that I have is power consumption and longevity of a battery. Like this ThinkPad, I have a stack of batteries at my house. So if I'm somewhere my battery gets low, I can pop it out, slap a new one in. A lot of the computing that I do on the go with different clients and stuff, because I did security consulting. Sometimes I need to bring my whole rig because I'm actually doing work, and other times I'm talking to clients, educating clients, doing things like that, and I don't need a real powerhouse. I just need to be able to get online through a LAN port, pull down information, write some simple documents, simple emails, stuff like that. So my use case isn't that much of serious computing. Now, obviously, you can build one for that purpose. There's a person that I talked to at Linux Fest Northwest who was thinking about getting a Minnow board and actually building a custom penetration laptop around that with all the different wireless antennas, Zigbee, Bluetooth, Wi-Fi, all those. So because you're building it, you can build it to whatever you want to accomplish. If you want it to just be a simple use, easy to use, you can do that. If you want to build something that's purpose focused, you can do that too. Any other questions? Okay. Thank you for coming. I hope you all enjoyed it.
Your customers rely on your website or application. If it's slow or non-responsive, it infuriates your users and costs you money. Keeping your business-critical systems humming along requires insight into what they're doing. Your system metrics tell stories that can reveal performance bottlenecks, resource limitations, and other problems. But how do you keep an eye on all of your system's performance metrics in real time and record this data for later analysis? Enter Longview, the new way to see what's really going on under the hood. The Longview dashboard lets you visualize the status of all your systems, providing you with a bird's-eye view of your entire fleet. Your customers rely on your website or application. If it's slow or non-responsive, it infuriates your users and costs you money. Keeping your business-critical systems humming along requires insight into what they're doing. Your system metrics tell stories that can reveal performance bottlenecks, resource limitations, and other problems. But how do you keep an eye on all of your system's performance metrics in real time and record this data for later analysis? Enter Longview, the new way to see what's really going on under the hood. The Longview dashboard lets you visualize the status of all your systems, providing you with a bird's-eye view of your entire fleet. You can sort by CPU, memory, swap, processes load, and network usage. Click a specific system to access its individual dashboard, then click and drag to zoom in on choke points and get more detail. Comprehensive network data, including inbound and outbound traffic, is available on the Network tab, and disk writes and free space on the Disks tab, while the Process Explorer displays usage statistics for individual processes. The System Info tab shows listening services, active connections, and available updates. Adding Longview to a system is easy. Just click the button, copy the one-line installation command, then run the command on your Linux system to complete the process. The agent will begin collecting data and sending it to Longview. Then the graphs start rolling. Use Longview to gain visibility into your servers, so when your website or app heats up, it stays up.
Citrix Zen Server gives you everything you need to integrate, manage, and automate a virtual data center, all on an enterprise-class, cloud-proven virtual platform, and at a third of the cost of other solutions. But why even bother with virtualizing your server infrastructure in the first place? Well, let's say you have a traditional one server to one application architecture, but you're running out of resources and performance is suffering. Once you order new server hardware, you'll wait for delivery, configure it, install your business application, stage and test the server, and finally, add it to your production farm. If you've been through this process before, you know it can take weeks or even months. You also know it's a manually intensive process that will burden your team every time you outgrow your current setup. With a virtual server solution, you could accomplish all of that in less than half a day. Server virtualization software separates the OS and application from the underlying server hardware. And with multiple virtual machines on a single server, you can use each of them to run different OSs and applications. This makes it possible to move your virtual machines from one piece of hardware to another whenever you want, to maximize utilization, simplify maintenance, or recover from a hardware failure, and without slowing down your applications or users. Clearly, server virtualization provides big benefits, and Citrix Zen Server provides even more. Since it's built on an open platform, Zen Server plays well with your existing hardware, storage systems, and IT management software, as well as with the industry's leading cloud service providers. Best of all, you can get started by downloading a fully functional, production-ready version of Zen Server for free. After a 10-minute installation process, you'll see how easy it is to start virtualizing your workloads and automating your IT management processes. And when you're ready for a richer set of management tools, just upgrade to one of the premium editions of Zen Server. So whether you're interested in virtualizing servers for the first time expanding your server virtualization footprint, or moving server workloads to the cloud. Download and install XenServer today and see how it can help you simplify your IT environment. Citrix XenServer. Do more. Don't spend more.
Your customers rely on your website or application. If it's slow or non-responsive, it infuriates your users and costs you money. Keeping your business-critical systems humming along requires insight into what they're doing. Your system metrics tell stories that can reveal performance bottlenecks, resource limitations, and other problems. But how do you keep an eye on all of your system's performance metrics in real time and record this data for later analysis? Enter Longview, the new way to see what's really going on under the hood. The Longview dashboard lets you visualize the status of all your systems, providing you with a bird's-eye view of your entire fleet. You can sort by CPU, memory, swap, processes load, and network usage. Click a specific system to access its individual dashboard, then click and drag to zoom in on choke points and get more detail. Comprehensive network data, including inbound and outbound traffic, is available on the Network tab, and disk writes and free space on the Disks tab, while the Process Explorer displays usage statistics for individual processes. The System Info tab shows listening services, active connections, and available updates. Adding Longview to a system is easy. Just click the button, copy the one-line installation command, then run the command on your Linux system to complete the process. The agent will begin collecting data and sending it to Longview. Then the graphs start rolling. Use Longview to gain visibility into your servers, so when your website or app heats up, it stays up.